Okay, guys, here we go. We're on to subtraction today. And here's the problem we're going to start out with. I just want to take you back to when we first did any subtraction problems at the beginning of this year, and I'm going to do it here in the bottom. And we said 5 minus 3. We did the same thing, very similar to saying this is 5 plus, and we changed that. Remember, subtraction became add the opposite. Just like when we had a problem, we used it mainly for dealing with problems that looked like this. Okay, what do you do when you're subtracting a negative 3? Well, we're going to 5, instead of subtraction, we're going to add and take the opposite of whatever the number is inside of here. So instead of subtracting a negative 3, we're going to add the opposite of that. We're going to add 3. So when we're doing polynomials, we're going to do a similar problem, okay? And I'm going to show you how we're going to do that. Here is the initial problem on the very top, and it's 3x squared plus x plus 7. I have that in parentheses, and we're going to subtract the whole polynomial, 4x squared minus 4x plus 6. We're going to subtract them from one another. So if we think about the concept we just talked about, instead of subtracting, we're going to add the opposite. We need to take the opposite of everything inside of here, okay? And it's kind of like the distribution property. So what really happens in this problem is we're going to, instead of subtracting, we're going to add the opposite of everything. Well, it looks really easy on this model. To add the opposite, we're going to change the signs, okay? So instead of subtracting 4x squared, we're going to add the opposite of that. What's the opposite of 4x squared? Negative 4x squared. The same thing with the second one. We're going to subtract a negative 4x. So what are we going to do? We're going to change the sign. It's just like distributing that negative throughout those parentheses, okay? So instead of a negative 4x, we're going to add the opposite, and we're going to add a positive 4x. And we're going to do the same thing to our, instead of subtracting 6, okay, we're going to add a negative 6. You're going to see how that's going to make this really simple, okay? So now we're doing the same thing as we did yesterday, and now in these polynomials, we have changed that to subtract, okay? So the problem now becomes, instead of subtracting all that, we're adding a negative 4x squared. You can see that here. So we distributed the subtraction there. And we distributed the subtraction to this problem. Instead of subtracting a negative 4x, we're adding a positive 4x. And we distribute the negative all the way to the end down here, and we're going to subtract, instead of subtracting 6, we're going to add a negative 6, okay? So we've just changed the problem, and we subtracted the whole trinomial, or the whole polynomial, and now we can, just like we did yesterday, when adding two polynomials together, we can zero out those that are the same, okay? So these are now all become zeros. I'll move the board up a little bit so you can see what that really looks like, okay? So I have a negative x squared left over. None of these are going to zero out. They're just going to combine together, okay? Now I can start zeroing these out. Oh, sorry. Okay. Zero out. Make 0. Make 0. Make 0. And what are you left with? Negative x squared plus 5x plus 1. If you go back to the original problem and you wrote them like we did yesterday. So I'm giving you more than one way to do this. We don't have to use the models. In fact, we don't want to use the models all the time. We want to use it to help us understand what the combination of combining all these together really looks like. So we're taking, just look at these initially, these like terms here, 3x squared minus 4x squared. We saw down here the representation. Here are the zeros, okay? And you're left with negative x squared. The same with this one, x plus 4x, okay, gives me 5x. That one's not too hard. 7, sometimes we struggle with this, plus a negative 6, 7 plus a negative 6. Here's all my zeros, okay. These 6 negatives cancel out or make 0 with 6 of these positives, and you have 1 left over, okay. Sorry that changed so quickly. I just wanted to get on to this next problem. I didn't want to save the time of me setting it up. Here's a similar problem. This is on page 365 in your book. It's try these A at the very top. It says 5x minus 5 minus x plus 7. So I used a model, right? Here's 5x minus 5. I change it to negatives, right? Subtract x plus 7, okay? So now we're going to change this, distribute the negative, okay? And we're going to subtract, instead of subtraction, we're going to change it to addition, okay? I'm going to change that really quick. I'm going to come back. You know that if I change that to addition, I'm just going to flip everything inside, okay? And I'm going to distribute, I'll go back. I'm going to distribute that negative into here and to there to subtract, okay? So when I do that, I distribute it to the x, and I'm distributing it to the plus 7. There were 7 positives. Now there are 7 negatives, okay? Now we're going to add these two together, okay? We're going to add them. So now we're going to make zeros, if I can, and I'm left with 4x once I do that, okay? I don't make any zeros here. This is negative 5 plus a negative 7, okay? And we know that that would give me, when I put all these together, you can count them all up, okay? And you would get a negative 12, okay? 2, 4, 6, 8, 10, 12. Okay, I'm going to pause and do one more, okay? It's going to be B on page 365. Okay, this one's kind of hard to see because you have, well, I'll come to that one here, 2x squared plus 3x plus 2. And over here you have negative 5x squared, okay, minus 2x, and then minus 9. And we're going to subtract everything inside of that. So just like we've been doing, we're going to distribute that negative into each one of those 3, okay? And when we do that, instead of subtracting a negative 5x squared, we're going to add 5x squared, a positive, the opposite. So we're going to flip those, and we're going to take the opposite, okay? And then we're going to subtract the negative 2x. That is like adding the opposite, okay? So I'm changing this now to addition, and we're going to add all of that. Now we're going to subtract a negative 9. We're going to flip all of these, and now we're going to add the opposite of a negative 9, which is a positive 9, okay? So we're going to take now, and I'll rewrite what it would look like. It'd be 2x squared plus 3x plus 2, and then subtracting a negative is adding a 5x squared. Subtracting a negative 2x is like adding 2x, and subtracting a negative 9 is like adding a positive 9, okay? Now we can see that together I'm going to get 1, 2, 3, 4, 5, 6, 7x squared. You can see them here. And then you're going to get 1, 2, 3 added to 2 more. You're going to get 5x. We're not making zeros on any of these. You have 2 here, and you have 9 here. 2 plus 9 is 11, okay? So remember, in subtraction, just like we've done always, we're going to distribute that, and we're going to subtract the opposite of the whole polynomial. I don't care how many terms are in there. It could be bigger than a trinomial. We're still going to add the opposite. Sorry this one was so long, but I'm going to give you some other ones to look at on YouTube to help you further figure out how to subtract polynomials, okay? Your assignment will be on Google Classroom, and I'm posting it there in about 5 minutes. See you guys. Have a great day.